Welcome out there. Hey, it is a great day in Summer School Mathline. I'm Ernie Roberts. I am your host for TNLearn's Mathline Summer School Style, all right? We're glad you've tuned in this afternoon. We are excited to be here. We hope that you're excited being tuned in and turned on to us this afternoon. Well, isn't that pretty good? Tuned in and turned on. I like that. Hey, let's see what we're going to be tuned in and turned on to today. Anyway, we've got mixed reviews on mixed number fractions. We're going to play with fractions today. And you know what? We're going to go a little deeper with them. Not just are they mixed number fractions, they are positives and negatives. You're going to love it. You're going to love it. A little bit of positives, a little bit of negatives coming along. So let's see. Let's go right into this game. Let's see what we've got going for problem-wise. All right. Looks good. I have 3 1/4 plus that's 6 1/2. I know we like those fractions to feel like they're more vertically. I'm going to restack them, okay? So I'm going to put 3 1/4. And folks, that is a negative 6 1/2 out there, all right? So mixed numbers, here we come, all right? And again, there's a positive and there's a negative. So guess what we're going to be needing to worry about is subtracting these values from each other, all right, somewhere along the way. This one has a bigger absolute value, doesn't it? So guess what? Ding, 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 it's negative sign for the final answer. Just keep that in your mind, all right? Now, the big question is, what do we do? What do we do? Well, we get common denominators. It's adding or subtracting fractions. Either way we do it, all right? So let's go for common denominator. This one's pretty nice. There's a 2 and there's a 4 saying, hey, let's make 4 happen here, all right? So it's 3 1/4, and we're going to put a plus, a negative, 6 and, well, we put a 4th there. See, we didn't change the 4 there, so we got to change it here. It's going to be 2/4. And now, dear friends, we can set this thing up. Now, it's a subtraction. Subtraction because the signs are different, right? You got it? You got it? All right. So, take your 6 2/4, put it on the top because it obviously is bigger than 3 1/4. And we're going to subtract 3 1/4. Easy one here. I gave you a common denominator and I didn't even make you have to borrow. Boy, I got to get to working on that, right? Let's see. We got 2 minus 1. That's going to be 1/2. Nope, not 1/2, folks. What do we get? 1/4. Yeah, 1/4 there because the 4s just hang along. They don't do anything. But the numerators, we do subtract. And you know what? We've got a 3 waiting for us right there. Looks like that was half of what we started with, or half of the big number there. Now, the question is, though, going back to context, that's what we got is 3 1/4. But we've got to come back here and decide what sign are we going to put on there? And let's do that. It's going to be a negative 3 1/4, all right? And again, if you were to, that's just what they work out to be because we're subtracting, right? So there's your deal. There's where it goes, and that's how it gets there, all right? Let's see what we got coming our way next here, all right? A subtraction problem. It says 2 2/3, and we are going to subtract 4 4/5. Already, folks, I can tell this 4 4/5 is bigger than 2 2/3. So the answer is going to be a negative situation here. That's the first thing. So remember, we're going to get a negative on our answer once all's said and done. Again, I'm going to put it in this vertical fashion. I'm going to put 4 4/5 leading the way, and then we're going to subtract 2 2/3. All right. Now, in looking at that, guess what we got to do? We need common denominators. So I'm going to play it out here, right across from here. A little different style on this one. No big deal. I like to show different ways that we can work through these. And how to get 15? You say, Ernie, wait a minute. Oh, because 3 doesn't go into 5 evenly, does it? So we don't go with the bigger number unless it's got a divisibility moment here, all right? There's no way 3 is going to divide into 5 evenly, so we're going to multiply those two guys together, and that's where we got 15. Now, you know and I know. I hope you know. Do you know? I know. Let's see. If 5 goes into 15, that changed, didn't it? So we got to change this numerator also. So denominator time, let's see. 5 divides into 15, it goes 3 times. 3 times 4 is going to give us 12. Now, let's keep a 4 slider right in there, okay? Just barely made it in. And over here, I've got 3 going into 15. I think that goes 5 times. Yes, it does. And then 5 times 2, pick up a 10. And keep the 2 right there, all right? Nice. Boy, I was nice to you guys again. We don't have to borrow, all right? But we probably have to borrow sometime in this game, all right? Just hang on. Just hang on to that. Now, we do 12 minus 10. It's going to give us 2. Bring the 15 along for the ride. Don't mess with it, whatever. And now we've got 4 minus 2, which is going to give us 2. And keep in mind, that's what we get from subtracting. That's not the final answer. Remember the final answer? We want to put a negative on here. So that is going to be negative 2 and 2/15 finished up, all right? And again, remember how you said, Ernie, how did you know it was negative in the answer? I have a smaller number minus a larger number. It's going to go negative. It's the only way it's going to fit. It's going to work out, okay? So that's your way. That's your indicator. The subtraction, you know, I like to put it like this because we're just basically subtracting 2 fractions. You put the right sign on the end. Just keep that in your head. Remember to do that. Remember to do that, okay? So there's a little bit of looking at adding and subtracting mixed numbers, tossing in a few negative numbers along the way with the positives. Isn't that fun? It was fun. It wasn't hard, was it? Just work it through like you know how to do fractions and you know the rules for addition and subtraction. How about it? Let's multiply. Let's look at our next problem. Let's do a little multiplication. Again, we've got this negative 4 and 4/5. Woohoo. And we're going to multiply that times, it looks like a negative 5 and 5/8 for us coming out here. Now, don't do it. You say, whoa, don't tell me don't do it. What do you mean? Don't say 4/5 times 5/8. That's not going to work, all right? This situation is, let's get improper fractions. You know what I mean by that? If you don't, watch and learn. We're going to take our negative 4 times 5, get 20. And then we're going to add 4. Now, I want you to know something, folks. Don't worry about that negative, all right? You say 4 times 5, which is 20, and add the 4, just like you would do if these were both positive fractions, okay? And that's going to give us, by the way, it's going to give us a 24 over 5. Now bring in the negative, because that's the sign of this whole value. So it says, do all the work here, then put a negative on it, all right? That's what we're looking at. Now, let's play the same game here. Cover the negative, say goodbye. For just a minute. Let's do it. 5 times 8 gives us a big old 40. Add 5. 45. Over 8. Don't change that. It's over 8. All right. Boy, you see all those 5s. You want to put a 5 down there. You saw one over there. Don't do it. Don't do it. There's an 8 sitting there. That's the deal. All right. And again, it's negative. So be sure you don't forget the negative. So we got a negative times a negative, which is good because it gives us a positive. Now, many times I tell you there's more than one way to work it. On this one, dear friends, I would not multiply 24 times 45 and 5 times 8 to save my life on this, all right? I see great openings here. Do you see great openings here? I see great openings here. I see an 8 that will divide into 24, goes 1 time here and 3 times there. That is awesome because the numbers just melted. All right, now let's go with the 5. The 5 will do its number in with the 45. It's going to give me a 9 and a 1 here. So if you're noticing, I hope you are noticing here, Ernie, it's just like doing regular fractions. It's just that we have to worry about a negative times a negative, which you know what? That gives us a positive. Yes, so the final answer looks like 3 times 9. I hope everybody's got that one on their tongue. Yeah, 27. It is a positive 27. Very cool, very easy and grounded to do there, all right? Watch your signs. Remember, negative times a negative gives you a positive. The rest of it, improper fractions and more improper fractions. Just multiply them together, work them together, all right? Let's take a look at division. Let's take a look at division here. We got a negative 5 and 1/2 going. We have divided by, I'm going to put the divided by sign so we don't let that kind of disappear into the problem, all right? And we got 3 and 1/6 hanging out here. I'll put it in parentheses just because some of you like that, okay? Now, let's work each of these individually. Once again, there's a negative divided by a positive. You know what that tells me? Answer is going to be negative. Don't worry about the signs anymore. Let's play the fractions now, okay? Again, negative divided by positive is negative. So cover up our little minus sign here for just a second. Let's make this happen. It looks like 5 times 2 plus 1. It's not the prettiest thing, but it's not bad either. Not bad either. It's going to give us 11 over 2. Remember, 5 times 2 is 10. Add 1 and put a negative onto that. Good job. All right. Now, we've got a divided by here. And I've got 3 1/6. Not the most pleasant of fractions, but not a bad one either. Not a bad one either. Let's see. 3 times 6, we're going to go through the routine. At least it's positive, right? And it's going to give us 18. Add 1. So 18 plus 1, thinking, is 19. And we're going to put a good old 6 underneath that, all right? Because that's what we started with. Now, it still says divided by. We're not changing the multiplication until we make a reciprocal happen here, all right? Don't get impatient and get out of step, all right? Let's do it. First fraction stays the same. Still say 11 halves or 11 divided by 2 or 11 over 2, all those lovely ways of stating that fraction. Multiplying, reciprocal, so let's interchange numerator and denominator. That's going to be 6 and looks like 19 going on there. Is that correct? That looks correct, all right? Now, time to, let's cancel. We got a cancel moment here. Let's do it because that makes the numbers just become smaller that we work with. So we got 2 that'll go divide into 2, and 2 will divide into 6, goes 3 times. I'm ending up with this, not so pretty looking, negative, 33 over 19? Does that sound good to everybody? Some of you say, I would like something to be better. Let's see what we've got out of that. That ends up giving us, it looks like, a negative 1 goes in there 1 time. Looks like I've got 14 left over. So negative 1 and negative 1 and 14 over 19. We don't bring a negative in with that part of the fraction. All right. So again, real quick check, just back through this. Make sure we always like to when we get these crazy numbers. Negative 11 over 2 looks good. They don't always come out pretty, do they, folks? And there we go. It looks like we are dividing 33 by 19, and there's your final value. Negative 1 and 14/19. Take that one to your bank also. All right. So it's just remembering your rules for positives and negatives. The rules for fractions are still the same. You look for improper fractions with multiplication and division. You look for common denominators with adding and subtracting. That's the best way I can explain it to you. Let's take a look at another guy here. All right. This one says, wow, we have x plus y, little evaluation here, substitution, if you will. So here's how we're going to work this one out. We're going to put it in there at negative 5 1/3, and we're going to add that to 3 4/5. All right. And again, I've already mentioned to you the signs. Oh my goodness, this is addition. Signs are different, so it's actually subtraction. Who's larger? It's going to be a negative answer. Okay, we're going to have a negative final answer. Let's do the subtract. Let's go ahead and get the common denominators. Then we'll do the subtraction off to the side, okay? This one looks like 15 is the common denominator we want to have. So let's see how this is going to work. The 3 is going to hang by itself, and we put a 15 right there. All right, I'm already noticing something here, but I'll tell you about it in a minute. We are going to multiply, see how many times 3 goes into 15. It goes 5 times, and that's what we're going to multiply this 1 by. So we're going to have 5. And remember, that's a negative 5 5/15, all right? That still keeps the negative charge on it, okay? Now, we're going to take, y'all going to take with me? I hope everybody out there? Good. We're going to divide 5 into 15. It goes 3 times. That's going to give us a 12 right up here, all right? Everything looks good. Everything's looking good. This is where we got to be careful. We're going to put this 5 5/15. And we're going to subtract 3 12/15. Please remember, in the end, this is just a subtraction. In the end, we've got to put a negative back on this thing, all right? But we're going to do the subtraction over here with the common denominators, all right? Problem. There is a problem. You can't take 12 from 5. This is the one I kept warning you we're going to see in just a little bit. Well, now we're seeing it. We got to work with it. So let's see. We're going to borrow over here from the 5, and we're going to make that a 4. You say, Ernie, what do we do that for? Well, because we got to add something to this 5 and make things better, all right? So we're going to add 15. We're going to pick up 15. Right there it goes. And you know what that gives us? A mess. No, it gives us 20. I like 20. Because you know why I like 20? Because I can subtract a 12 from 20 and I get 8. I get 8. And I get 8 over 15, or 8/15. And now I've got a 4 minus 3, which gives me 1. Now be careful. That's the big chunk of the answer, but you need to come back over here and make sure you remember It is a negative 1 and 8/15, because again, this negative guy is bigger than that when you look at their absolute values. All right, so there's your story on this one. Signs are different. Subtract and take the sign of the one with the largest absolute value. Easy, easy. All right, let's take a look at our next one here. We've got a great problem here. It looks like the same fractions again, which is nice because I don't have to worry about putting them together again. But let's see what's happening. This time we've got a negative 5 1/3, and we are subtracting a positive 3 4/5. You say, Ernie, that looks like the same problem with one exception. Remember what happens when we work with subtraction? Add the opposite the second. So let's keep negative 5 1/3 here. We're going to add a negative 3, and I'm going to put a parenthesis there because I know a lot of you like that, around it. It is a negative, so it is adding two negatives. We know the answer will be negative, and it's going to be whatever these add up to give us together. So let's play it out. Let's go for those common denominators once again. Well, we already got them once. Let's use them again. We got a 15. And you know what? We've got a negative 3 going here. And we got a 15 going here. All right. Now, play it out. We said it was 5 earlier. I hope it still is. We've got a 5. We got 5/15 there, right? Okay. Now, we've got 5 going here. We got 12 this time. Now, folks, it's an addition game here. We're going to add the 5 and the 12, and we're going to add the negative 5 and the negative 3. So it's going to give us a negative 8. And then we get 17. Is that right? 17 over 15 looks like to me. All right, 5 plus 12 gives us 17. Little bit improper there. Top-heavy fraction. Denominator is going to be fine. The numerator needs a little work. All right. So what we're going to do, we're going to divide that 15 into 17. It goes one time. And we're going to tack that on because once again, folks, we're not adding 1 to the negative 8. We're adding 1 to 8, and then it's going to become a negative 9. All right, so that's the story. So that becomes negative 9, and we keep the 2/15. All right, there's your final value there. So again, the negatives, don't let them get you upset. Remember, that's just the sign of the answer. You still work this part out like you always would, and then put the negative back on it in the end, okay? And it works beautifully. It's a great little way to make sure the right answer is right, okay? How about it? Adding and subtracting, not bad, was it? All right, let's go to multiplication and some division here with these guys, all right? I've got 5 and, it says multiplication, doesn't it? So we're going to multiply. So we're going to take 5 1/2. We've been using that one a lot today, haven't we? And we're going to multiply it times a negative 1 3/11. Yeah, so much for the pretty one there. Now, let's see how this is going to work out. This is, first of all, going to give me that 11 over 2. Actually, I think this is going to be a nicer situation, just saying. And we've got this negative something. Y'all remember what to do with the something? Let's multiply this 1 times 11. Gives us 11. Add 4. We're going to have a negative 11 plus 3, which is going to give us what? 14. Let's say a 4. I meant 14. That's what we've got there. That looks good. All right, once again, let me go back through it one more time here. We have 1 times 11, which is 11. Add 3, you get 14. By the way, over here it was 5 times 2, which is 10. Add 1, 11. Sometimes I forget and think, y'all have this down, but I want to make sure. Again, I love the 11s because they're going to cancel. That just saved me a lot of work. Saved you a lot of work out there at home. Let's look at the 2s. How about it? 2 goes into 14. Do you see what's going on here? Y'all see what's going on here? This is looking good. Goes into 7 times. It's still negative. All right, still negative. In fact, it's the only thing left is our negative 7. That's the only thing left of everything else is 1s. The answer, how about that? Negative 7. I guess you'd call that your lucky 7 in a negative way. I don't know. All right, but there's your story on that. Good problem working with us there. All right, let's take a look at, got division, I'm sure, coming up. Let's take a look at this division problem coming up here. It says x, and by the way, that's the division sign. That's what that means, all right? X divided by y. And let's see what we're going to do with it. We are going to pick up negative 4 1/4. And I'm going to write it with the division marker here. 1 and, how about it, 1/8. We got it going. We're looking good. Improper fractions with division. You've got to do it. Remember, with multiplying and dividing, it's all about improper fractions. So let's do it. Forget the negative again. By the way, don't forget this one. We got to put that in there because we're going to be a negative divided by a negative. It's going to give us a positive. But right now, let's not worry about this one. Let's make this improper, and then we'll put a negative attached to it. How about it? 4 times 4 gives you 16. Add 1. I'm getting 17 over 4. We're going to divide. We're going to divide that by. Worry about the negative. We'll put that negative on here in just a minute. 1 times 8. Add 1 to that. You get 9. You got 9 over 8. Folks, both of these have negatives, all right? Can't lose them. But when we do the division, it's going to go positive. It is going to go positive. So remember that. Remember that. It's going to be all right. Let's go ahead and make these little guys become reciprocal oriented, all right? So we got 17 over 4. Keep the first alone. Multiplication. Remember, we're going to multiply. And keep the negative on that reciprocal. Keep it there, all right? And you say, Ernie, can we put it on the bottom? Yeah, we can put it on the bottom. We can float it. We can do a lot of different things with it, but just be very careful with it, all right? So here we go. We've got this 17 over 4 kicking over here. We've got now 8 over 9. Remember, you went with the reciprocal, and we still have 2 negatives, which is going to give us a positive. So signs are easy. I see we need some help. 17 is not a pretty number times 8, all right? And here we go. We got 4 and 8 going. Give me a 1. Got a 1. Everybody got a 1 out there? Yes, And divide 4 into 8, you get a 2. And I'm seeing 34 divided by 9, or 34/9. Let's mix number that just for those of you who like mixed numbers. It will go in there, divides in there 3 times. 3 times. And 3 times 9 is 27. Whew, I've used up 27 out of 34. That means I have 7 left over. Drop a 9 under there. Again, when you do this reducing business, some of you get nervous about that. It's 3 times that, it's 27. That means we have 7 left over. That goes in the numerator. The 9 always stays in the denominator. There is your final answer. And it is positive because a negative divided by a negative is positive. All right? So, easy, easy, easy. It is. You know the rules, right? Let's look at one more here. Let's take a look at this one. Oh, Ernie, 3 expressions. Are you serious? Sure. We're always serious here on Mathline. Not necessarily, but we are today about this one. We are definitely going to do this one, all right? So let's start it off here. Let's go back and say, replace x times y. We'll do y times z. Then we're going to take the results. And you say, Ernie, what are we going to do with 0? Is it positive? Is it negative? Well, we may not need to worry at all. Let's just check this one. Take it one step at a time. Everybody gets all excited when they see 3 numbers. I know. So let's see. We've got -7 times 1 5/7. Woohoo! That deserves a parenthesis. Even though you don't have to have it, I'm going to put it there so we don't forget. Then we have another multiplication that we need to do, which is 1 5/7 times 0. I like that. Y'all know why I like that? Because anything times 0 is 0. That's the easy part. That's awesome. This one we got to work with a little bit, all right? So we have -7. Let's do that improper fraction game. 1 times 7 is 7. Add 5. Plunk in a 10. No, not a 10. You're jumping me here. 12. 12 over 7. All right. I don't know where that 10 came from. Anyway, drop a 1 underneath that while we're at it. And that's going to give us some fun here, all right? Over here, well, guess what? We have nothing, okay? And we represent it with a 0. So there's a nothing. But what's cool here is we got a nice cancellation going. Our 7s go. It becomes a -1, but that -1 does not disappear, all right? We've got a -1 times our 12. That's going to give me a -12. So basically, we got -12 minus 0, and of course, minus 0, it's the identity element for subtraction and addition. It's just going to give us -12 here at the end. Not bad. What looked like a pretty scary problem turned out not to be very scary at all. Zeros are kind of nice. They really are. They either work as an identity for addition, which we can't mess up with, or they just wipe things out totally with multiplication. Just remember, you can't divide by 0, but otherwise, it's a good, friendly guy, all right? Or friendly lady, I don't know which. It's neutral, it goes either way, right? So anyway, thank you for tuning in this afternoon to TNLearn's Mathline. We've been in summer school. We're feeling like summer today, aren't we? I hope you had a good time with the show we have here. And mixed numbers, fractions, positives, negatives, piece of cake. If you know your rules, practice them, and you get them down up here in the head and on the paper. It's great. It's a great way to go. You know what? We've got summer school still running loose for us a few more weeks. Going to be back live August the 8th. Keep reminding you of that because we want you to know you will get to call in. But you know what? Keep giving us your papers. Keep giving us your letters, your emails. And you know what? I'll see you again next time, and we'll do some math.